So gather round if you want to know how to score well in report or assignment 1. Now the guidelines to do that are on the web page. I'm not going to move the camera around. Report guidelines and grading criteria, which is on the coursework tab inside the CE721 web page. I'll just pop it up on the screen. Okay, so that's the format of any report in our school. Broadly speaking, abstract, introduction, main body, conclusions, references, appendices. Now that doesn't mean to say that every section is called abstract, introduction, main body, conclusions, references or appendices. It doesn't mean that at all. That's just the general form of any report which is in a science department, okay? So what would you have in the abstract? Well, this work documents the design of a printed circuit board ready for production as part of the CE721. The circuit examines the possibility of constructing a, you can open a copy of this, haven't you? Of designing a circuit board, a printed circuit board, to automatically turn lights on and off according to whether it's night time or day, that kind of stuff. Introduction, what's going to be in the introduction? Well, what you're doing, using multi-sim, you're relatively new to printed circuit board design. You're going to explain what a simulator is, what a simulator isn't for that matter, and kind of the background of how you arrived in this position, and what your objectives are as well. The main body part, well, that's where you're going to describe what you're doing. You're probably going to go into detail on footprints inside there. You're going to go into details about why you've made the design decisions you have. So in other words, why is the light-dependent resistor on one side as opposed to the other side, etc., etc. At the end of that, you probably conclude that you'd like it to switch mains, but you're not allowed to switch mains inside this lab, so all you've done is just switch to load in. Some of you will only be switching an LED. Well, that's fine as well, but a little bit of information about actually what would make the circuit useful or more useful would be for it to be able to switch some kind of high voltage or high current. Conclusions, what goes in the conclusions? Meaningful things, not we built a circuit and it works. That's not a conclusion. A conclusion is this circuit was designed using multi-sim, which is a reasonable platform, but has a few problems associated with it. Most particularly in the design of the shape of the curves on the side of the printed circuit board. That kind of comment, that kind of comment. Any difficulties that you have, any challenges, that's the sort of thing which goes into the conclusions. So if someone picks up your report, not that they should, but someone picks up your report next year, they think, aha, I know how to score higher marks because this student told me some of the difficulties or challenges which occurred while they were doing it. I built it, it works, I enjoyed it. That is not a conclusion, that's extremely weak and would attract very weak marks. Now, for the award of the marks, well, we want everyone to pass, of course, so we give a nice 10% just if it looks all right. So, you know, has it got the headings in the right places and section numbers and are the figures labelled and what? Can you write a professional report? Of course, you know. Circuit diagram. So you've got a circuit diagram and that needs to be laid out quite neatly. Now there's various ways that you can do it in multi-sim. You've seen that you can do it in all a tangled mess, or you can do it in a nice kind of way that you'd normally see a circuit laid out. So there's some grades associated with that. References, citation, you'll note there's only 5% for circuit diagram and 5% for references and citation. One reference, using the reference that I found for that particular circuit, that's not really going to attract a huge number of grades, is it? So what I'd like to see there is that potentially you spent 5 or 10 minutes looking around either in books or on the web for other circuits. So here's some other good ones. This one, if I have my time again, this might be in the conclusions. If I had my time again, I think I would build this one in preference because it's got 3 components less or something like that kind of stuff. But remember to use the square brackets in the text, so when you're saying circuit 1, I would expect to see a square bracket next to it with a number in it referencing down to the bottom. So your citation should be in your text and your references should obviously be at the end. PCB layout, now that's a matter of discretion, and I'm allowed to make discretion, that's why I'm a lecturer here. And in my opinion, there's good layouts and bad layouts, okay? So you're going to get some marks assigned for that. Publicity, that seems an odd thing to say, but publicity, when you read something, obviously you're going to absorb it and I'm going to mark the text which is there. But as far as publicity is concerned, well, it's nice to see the real thing sat on the desk, right? It's nice to see the representation of what it looks like in multisim when it's in the real world. It's nice to see a photograph of a piece of breadboard or a Veriboard. It's nice to see, if you did go as far as getting the PCB made done, a picture of that. Okay, so that's what I mean by publicity, the sort of magazine type of stuff that you see. Because let's face it, when we read a magazine, there's about that much text and about that much pictures, right? So that's what I mean by that. Evidence of measurements. Now, we come back to this. I built a circuit and it worked. You expect me to believe you? Well, of course you're going to put that it works. But I want evidence that it works. So you've done something. How do you verify this circuit works? It's difficult. We should have them now, some light-dependent resistors. But if we haven't got those light-dependent resistors, you can obviously do it with a potentiometer, and you're all doing that, aren't you? So, at what point does it switch on? At what point does it switch off? When you adjust those potentiometers, evidence it to me. So take a screen grab of the point at which the output voltage jumps high or jumps low, all of these kind of things. Evidence, I want evidence. Yeah? Justification of choice of circuit. Well, if you copied the one that I did, which I think everyone has actually, I'd still like to see you justify why it's a good circuit. It's good because it's an operational amplifier and it's about as simple as it gets, but justify it. What makes it good? What makes the other ones that are similar to it less good or more good? But justify what it is that why you think that you chose that circuit. Critical reflection on achievements. Now this is most likely going to be in the conclusions part, but criticise what it is that you did. So it took me longer than I expected to be able to learn how to use multisim effectively. It was several hours before I realised that I could forward annotate from multisim into that kind of stuff. So you're being critical of yourself. Now that doesn't mean I read that and think, ah, good, I can knock some marks off. Quite the opposite. If you're reflecting and you're self-critical on your design process, you will get more marks rather than less marks. Because anyone reading the report wants to know the problems. They want to know the successes as well, of course, but they want to know what difficulties that they might encounter if they do the same thing. Simulation in multisim, so that's really similar to the evidence of measurements, but inside multisim, I want you to convince me, absolutely, that you've used multisim and that you haven't just got it from somebody else, if you see what I mean, because it becomes very obvious if someone plagiarises to me, because I know which report is the good one, and I know which one is just the one that somebody else has borrowed heavily from. And finally, the evidence of operation. Now, I acknowledge that some of those have got overlaps in between them, but that's the basis on which I shall be performing the grading. Is that okay? Now, one of the things which I will insist that's in there, and it's kind of implied in the simulation in multisim, it's kind of implied in the explanation of operation, but I want a bill of materials, or what's called a BOM, and Mike Walton's going to give you a little talk very shortly about how to produce the bill of materials. And also, this comes under the PCB section, I want those Gerber output files, or I want evidence, discussion, that you've produced those Gerber output files. Now all that really is just the layers that you see inside Multisim when you go into Altiboard. So it's really just exporting the silk layer, the copper layer, the whole layer. So it's all of those things pulled together, and Dr. Walton is going to take you through how you do that. I'll get him to draw a circuit first so that he can do that with you, and he will show you how to get those files into the correct format so that you can send to PCB way. So you're now very dangerous in what you can do, because you can design a printed circuit board, you can send it off, and in 3 days time, 2 days sometimes, when it comes back by air freight, you can have that PCB in your hand ready to populate. And we have a limited budget, I mean we're talking hundreds here, but we have a limited budget that if you meet a particular time deadline that we set, we'll send them off for you. It's as simple as that. But it's not compulsory in this one, but it is compulsory in the next one. I want to see that PCB. Whether you populate it, that's a different thing, but if you do populate it, by populate it I mean solder the bits on, but if you do populate it, you will get more marks than someone who doesn't populate it. So there is a desire that we see something working at the end of this. But for the first assignment, will someone get more marks if they've prototyped it on Veriboard or breadboard? Yes, they will, because that's evidence of operation. Okay, so they'll pick up on that particular piece of grading there as well. Now it's the 14th, 28th, 30th, so we've got about 3 weeks to do this, haven't we? So I think most of you have got your simulations working, you've got your printed circuit board designed. So now really is the time to think about getting some of those pieces of breadboard and doing some real electronics and putting it together. Now again, you don't fully have to understand what you're doing to be able to analyse that circuit. You've already done it under Multisim, it's pretty similar in the real world. But this is where the real problems start. Okay, any questions on the grading? And I'll upload this onto the Moodle page, well, it's on YouTube, but a link to the Moodle page.